Quiz. Under basic conditions, which side of the epoxide gets attacked? Does basic attack care more about substitution or about strain? By the time we get to Ninja Level 3, you'll be able to call it in under 1 second. Let's open up some epoxides. Let's start at the beginning, Ninja Level 1. Opening a terminal epoxide. Basic conditions use good, strong anionic nucleophiles, and good, strong anionic nucleophiles react like SN2 reactions. And SN2 reactions are governed by sterics. The more sterically bulky the electrophilic carbon, the less likely we're going to do an SN2. The same is true with epoxide opening under basic conditions. Our nucleophile will prefer to react with the least sterically hindered carbon, because that's the easiest one to access. Then we open the epoxide, put the electrons onto oxygen. The epoxide opens to form the O- on the same stereochemistry because carbon 4 did not get attacked. We'll finish this reaction out with some paperwork, a proton transfer to the end to neutralize the oxygen and form our final product. The epoxide opening under basic conditions for a straight chain terminal epoxide is about as straightforward of an epoxide opening as you're ever going to see. Under basic conditions, the anionic nucleophile attacks the less substituted side of the epoxide, and the stereochemistry on the spectator carbon does not change. Because we started with only one stereoisomer of the starting material, this is the only stereoisomer of the product that will be formed. At Ninja Level 2, things change a little bit for an internal epoxide, but not that much. Under basic conditions, the anionic nucleophile will still act like an SN2 reaction and still attack the less substituted side of the epoxide. The difference here is that this carbon is a stereocenter, so we will have to attack from 180 degrees opposed to invert the stereochemistry at that position. The oxygen on carbon number 4 is coming towards you as the viewer, so the nitrile epoxide has to come in from the back and will be on a dash in our new intermediate. Again, carbon 3 did not get attacked. It's a spectator in this mechanism, and its stereochemistry will not change. The final step is the same. Proton transfer to the end gets us to our product. Opening an internal epoxide isn't that much different than a terminal epoxide, except for we change the stereochemistry at the attacked position. Again, because we started with a stereo-defined starting material, we only form this stereoisomer in the product. Ninja Level 3 looks at the implication of a symmetric epoxide. With a symmetric epoxide, neither side of the epoxide is more or less substituted. So how will a nucleophile know which side to attack? It will attack both, without preference. Some of the time, the nucleophile will attack one of the carbons, and some of the time, the nucleophile will attack the other carbon. And that will form a mixture of two possible intermediates. We'll finish up, as we always do, with the proton transfer to the end. The products take the same form that we've seen before. The mechanism goes through the same mechanism we've seen before. The Ninja Level 3 issue here is that we formed two products. What is the relationship between these two products? Are they constitutional isomers, completely different molecules? What is the relationship between these molecules? As drawn, that's a bit tricky to see. So let's flip one so that the carbon backbone is drawn in the same orientation. If I flip the one product like a pancake, that aligns both of the products so that both of the oxygen groups are on the bottom right and both of the alkynes are in the top right. And in this orientation, it's easier to see that we have two stereocenters. Both of them have changed their configuration. These are a mixture of enantiomers. And that's very interesting because we started with a stereo-defined epoxide. Typically, we get a mixture of enantiomers when we have a common intermediate, often sp2 hybridized that's flat trigonoplanar, and reaction can happen on both faces without preference. Here, we started with a symmetric epoxide that could have attack on either side of the epoxide without preference, and that's how we got our mixture of enantiomers. Ninja Levels 1, 2, and 3 have all been variations on the same theme. Ninja Levels 4 and 5 are going to continue with that theme and push our boundaries of stereochemical analysis. In the previous example, we had a symmetric epoxide and we opened it with a nucleophile to break that symmetry. Ninja Levels 4 and 5 are going to look at sodium hydroxide as the nucleophile. When sodium hydroxide acts as the nucleophile, it will open up to form a second alcohol on the epoxide. The nucleophile by itself won't be breaking the symmetry at this point. So let's draw out the reactions and see what happens. Here we have a symmetric epoxide where neither side is differentially substituted, but I want to point out that this is a cis epoxide. That will be important later. Since there's no difference in substitution, the nucleophile can attack either side of the epoxide without preference, just like we saw last time. In the intermediate, depending on which side of the epoxide got attacked, that carbon will invert its stereochemistry to add an OH group. The other carbon, the spectator carbon, will remain on away. As always, we'll finish with our proton transfer to the end to neutralize the oxygen and form our product. The mechanism doesn't look all that complicated, and we formed two products. We just saw that in the last Ninja level. Big jump here is that this product is palindromic. And what I mean by that is it can be read the same way in both directions. Methyl group, alcohol, alcohol, methyl group. methyl group, alcohol, alcohol, methyl group. Same way, both directions. When we look at these molecules then, and we look at the relationship between these molecules, we need to be extra careful because it's palindromic. These molecules have two stereocenters, and on its face, it looks like they have both changed their configuration. Let's do one more check to be sure. Let's flip one of these molecules like a pancake. When I flip this first molecule like a pancake, I see that it's identical to the first molecule and still different from the second molecule. Furthermore, when I assign stereochemistry labels, the one molecule has two carbons that are S configuration, and the other molecule has two carbons that are R configuration. I'm glad that we checked. These really are two different products, and so we have a mixture of enantiomers in this example. Let's check out Ninja Level 5. With Ninja Level 5, let's look at opening up a trans-symmetric epoxide. I'm going to leave Ninja Level 4 up here so we can compare and contrast at the end. The mechanism will still be the same. The epoxide could get opened from either side with this strong anionic nucleophile because there's no differentiation between the two carbons. The intermediates will look the same. Just watch out for the methyl group that's out of the plane in each of the examples. The hydrogen here is in the plane. That's the consequence of having a trans epoxide in our starting material. Still neutralize the charge, still proton transfer to the end. Again, the mechanism here really isn't the issue. It's the same mechanism we've been seeing the whole time. As we look at these two products, we'll need to ask ourselves, what is the relationship between these two products? And to be honest, it's kind of hard to assess here when we have the hydrogen in the plane. We can do it, but that's not the typical way we draw these molecules. Let's rotate around the center bond to get the methyl group back in the plane like it should be. Now that we've done a 120-degree rotation around that central bond to get the methyl group in the plane, this looks more like a more typical presentation of a product, and we can assess the relationship between these products. They look like they should be enantiomers, don't they? They've got two stereocenters, and it looks like both of them changed their configuration. Let's do one more check. Let's flip one of them like a pancake and see what happens. When I flip this molecule like a pancake, notice what happened. These two molecules are identical. And that means actually all three of these molecules are identical. They're all the same molecule drawn 3 different times. 5 different times if you include the times we drew them over here. The product of a trans epoxide opening to make a diol gives one product that I've got drawn here 5 different times. This one product that I've got drawn 5 different times, it is meso. It is meso and achiral. This is one molecule for this product. Once we drew it in the form where all the carbon groups were in the plane, we can see that there is a plane of symmetry in these molecules. And that's our clue that these are not really different molecules. These molecules are really one molecule drawn 3 different times. And if I look at the stereo labels for these molecules, once I flip this molecule over, these carbons have the same stereochemical identification. This is one molecule, and it is meso and achiral. This subtlety between cis and trans symmetric epoxides is really nuanced, and it's really the whole reason for Ninja Level 5 here. We have to watch out when we're adding 2 of the same functional groups to a product. If that product becomes palindromic, we have to be very careful whether they're really a mixture of enantiomers or whether we've actually drawn the same molecule twice and have made a meso molecule. What about you? Is there an epoxide opening that always trips you up? Leave it in the comments below. I'll take a look at it for you. With these pro tips and subtleties under your belt, you're ready to tackle any epoxide opening under basic conditions.
Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.